Okay, let's look at exam 3A, problem number 1. Right? So boat is being pulled toward the dock. So I'll put a boat right here. And the dock is probably around here. Right? And if the rope is being pulled by a winch located 6 feet above the dock, so you have winch is going to be up here. Right, so this is going to be 6 feet, right, and at the rate of 3 feet per second. Okay, so here's the rope right here, right, this is being pulled at the rate of 3 feet per second, right, and how fast is the boat approaching? So we want to know how fast this guy is going right here. So feet per second. When a boat is 8 feet from the dock, so here is 8 feet right here. All right, so we need to give variables to a moving quantity. So the distance between the boat and the dock is changing. So I'm going to give a variable for that. So I'm going to call that x, right? And here's a rope. Length of the rope is changing too. So I'm going to give r for that, right? By Pythagorean theorem, we know that we can have, let's see, Pythagorean theorem. Right, by Pythagorean theorem, we can set up an equation, right? So it's at x squared, so x squared plus, right, 6 squared, so that's fixed, height of the winch is equal to r squared. So that's the equation, right? Then other given quantities are, so maybe I should say given, right? Right, so x is 8 at this moment, so you have x equals 8, right? And the rope is being pulled at the rate of 3 feet per second, so the rate of change of the length of the rope with respect to time would be, rope is getting shorter, so it's going to be -3, right? And we can find r by just using the Pythagorean theorem. So in this case, I'm going to probably go here. R is going to be square root of, right, x squared, in this case 8 squared. 8 squared is 64. Maybe I should write it this way. Right, 8 squared plus 6 squared, right, which is going to be, right, it's a square root of 8 squared is 64, 6 squared is 36, so that's 100. So square root of 100, actually, that's really nice. It's actually 10. All right, so we have that. All right, now we can just take the derivative, because what we're looking for is the rate of change of x with respect to time. So we're looking for dx over dt, right? So this is what you're looking for, right? So let's take the derivative. So derivative of the Pythagorean theorem here. So I'm going to just go here, right? We need to take the derivative with respect to time, right? Derivative of x squared would be 2x. Then you have to multiply dx over dt, right? Derivative of 6 squared is a constant, is 0, right? And so this is equal to derivative of r squared is 2r dr over dt, right? Right, then we can just divide both sides by 2x so that we can isolate dx over dt. So divide by 2x, right? So you will get dx over dt is equal to, right, 2r over 2x dr over dt, right? And you can cancel 2 and 2, right? So you will have dx over dt, which is what we're looking for. And we actually know all these numbers, right? R, so this R is 10 right here, right? So it's 10 over, right, x is right here, x is 8, right? Then dr over dt is given to be -3, right? So we can cancel, let's see, 10 divided by 2, so it's going to be 5, divided by 2 is going to be 4. So this is going to be -3 times 5 is 15 over 4, right? So therefore, the boat is being pulled at the speed of 15 over 4 feet per second, right? So this is the answer, right? That's it. I hope that this was clear.